Today we're going to be talking about PHP security in Userland, which is specifically focusing on the application side of things. There's some things we're not going to talk about, some things that we are going to talk about, and I wanted to be very clear on exactly what we're going to cover in today's agenda. So the first thing we're going to do is talk about the application that we will be securing. Today's workshop, we're actually going to take an application that does something trivial, but it still does something, and it has zero security built into it. And we're going to go through step by step and add security to the application. That way, you get your hands dirty and you get some experience actually implementing these different security practices in PHP. We're going to start with talking about an overview of the different security features that we're actually going to focus on, because, like I said, there are some things we are going to do, some things we aren't going to do, and I want to give you a little bit of insight into what exactly it is we're going to do. Then we take a break. I say 5 minutes, that might be more than 5 minutes. This is when we're going to get all of our environment set up, throw projector remotes to the ground, and make sure that we all have everything that we need to actually work through the workshop itself. The very first topic we're going to deal with is authentication and password management, which, remarkably enough, is something a lot of applications get wrong. The goal is, after this, you won't be one of those applications that get it wrong. We're also going to talk about account recovery, which is kind of a compromise of accessibility or usability versus security when you have multiple ways to get into an account. So there are some ways that you can do this right, some ways that you can do this wrong. We're going to talk about one approach that is a way to secure it, and different ways that you can even make that stronger. Then we'll take another break, because that is a lot of work that we're going to do right there. And then we're going to come back and do even more work and talk about two-factor authentication, which is really cool and also incredibly complex. If we have time, I will get into push notifications. When I did the entire walkthrough of this entire workshop last night, it took me about 4 hours to go through all of it. We don't have 4 hours today. So we're going to get through as much as we can. All of the code is available on GitHub, so you can take a look at it later. All of the slides are already posted to SpeakerDeck and joined in, so we can go over it afterwards there. And I will walk you through everything anyway, even if we don't get time to do it hands-on. Push notifications, even if we do get it that far, is going to be demonstration only rather than hands-on work, because it is incredibly difficult to get set up properly. But there are organizations that can help you get it set up later. Then we'll take some time for open discussion if you have any specific questions that you wanted to ask or any specific features that you wanted to know more about. So first, let's talk about the application, RNG coin. We're going to create our own knockoff of Bitcoin because it's fun, it's snarky, it's very relevant with modern technology, and it's something where if you come to my talk tomorrow, you'll see how Coinbase, which is a Bitcoin marketplace, made a lot of mistakes in terms of authentication and actually violated a lot of people's privacy as a result. So I figured, why don't we try to see if we can do it right the first time? Simple application. We're just going to be storing and exchanging a fake cryptocurrency. Now, before any of you ask about an ICO, this is not a real cryptocurrency. There is no real value. All of the value is generated by random bytes on your machine. There is no blockchain involved. So yeah, don't worry about blockchain. The application has specific things that we need to do. First thing, we need to deal with actually logging into the account. The application as it stands right now is kind of like the setup. You can log in with any password you want because it's not doing anything with password-based authentication. We're going to fix that. We're also going to kind of like give it an overview of your current balance, so it has some data storage built in. We also need to be able to recover an account if you lose your password. How can you securely reset your password without making it so that a third party can steal access to your account? We're also going to add some proactive confirmation of transactions. So when you buy or sell your RNG coin, making sure that you are actually authorizing that transaction. These are just a few of the different things we're going to go through. The sky's the limit with what you can do with security, but this is all we really have time for today. And even though it's a 4-item list, it's a lot. There's a lot there. First things first, we're going to talk about the different components of security that we're focusing on today. The first one is usernames and passwords. Usernames in general are not private information. A lot of organizations will use your email address as your username or your real name as your username. Usernames are not private. They are unique because they identify you. but this is just identifying information, not authentication information. Has anybody ever heard the phrase authentication versus authorization? How about identification versus authorization? These are all three very interrelated concepts. Identification is figuring out who you are. Authentication is verifying, making sure you actually are who we think you are. And authorization is making sure that the action you are trying to conduct is the action you're trying to conduct, and you are allowed to execute that action. Three interrelated concepts with very large words. Usernames are specifically identification, not authentication, not authorization. Like I said, you could use an email address. In some cases, you should use an email address. We are going to use email addresses today just because it's simple. Account recovery works really well with email addresses, but email addresses are also inherently insecure. Email is really easy to bypass. Emails are sent in the clear from one server to another, so if you use email as the only way to authenticate somebody and try to send a message from one server to another via email, it could be intercepted. A malicious third party could take control of that. Or if you're hosted on a .io domain, somebody could randomly buy the entire .io namespace and reassign your email address to another server. I say that because that happened last month. Somebody actually managed to buy one of the root DNS servers for the entire .io namespace and controlled every .io domain anywhere for about an hour. So it's pretty catastrophic if you rely on some system like that is so completely outside of your control. Passwords should never be stored in plain text. Let me say that one more time. Passwords should never be stored in plain text. Passwords should also not be encrypted. If anybody ever sends you a "we will remind you what your password was" email, don't use them. Again, if an organization knows what your password is, they could leak that information to a third party, to an attacker. Should never be stored in plain text, should never be retrievable in plain text. Instead, you should hash them using a known, stable, secure algorithm. There are a lot of well-known, well-implemented, highly insecure hashing algorithms in the market. MD5 is one of the most common ones. WordPress, for example, still uses MD5 hashing for passwords, and MD5 is known to be an exploitable, broken hashing algorithm. It is trivial to guess somebody's password given an MD5 hash. So we want to use known algorithms, stable algorithms, strong algorithms to protect passwords. Hashing should also be constant time. Any sort of a password lookup should be constant time. We will get into more of what constant time means later when we get to account recovery. Just remember, constant time when you're comparing different strings used in authentication is important. Hashing should also be somewhat expensive. When you hash a password, it takes a certain number of CPU cycles to actually compute the hash. As computers get faster, it becomes easier to compute hashes. Hashes that were considered secure 5 years ago are insecure today, not because the hash has gotten weaker or because there was something wrong with the algorithm, simply because our computers have gotten that much faster. For example, one of my former coworkers had a 512-bit key that he used for authenticating to all of these different systems. And we pointed out to him that he shouldn't do that. He said, well, I don't know why. It's been secure for the last 15 years. It should just be fine. So we took a lunch break and hacked his account by regenerating the key. Because a 512-bit key that 15 years ago was considered super secure, you can break in like an hour and a half. So different encryption algorithms need to be stronger. Key lengths continue to get longer as computers are more capable. Hashing, you want to have a certain work factor applied. PHP has some sane defaults for password hashing right now, but you can always increase those to make passwords incrementally harder and harder to hash. The value there is to slow down an attacker, because an attacker who is attempting to brute force their way into an application will merely guess password after password after password after password. For an individual user supplying a password that they know, hashing, even expensive hashing, is trivial. It's maybe a few milliseconds, a couple hundred milliseconds. It's not that bad. But if an attacker is coming to hit your website, and you know it's going to take them 100,000 guesses to guess a password, and they can guess each password in a millisecond, it's 100,000 milliseconds to break their way in. If each round of password hashing requires 100 milliseconds, Now it's, what, 1 million milliseconds before they can actually breach in. And at that point, you can set in a bunch of other delays and a bunch of system-level preventions to keep people from actually getting in. Hashing should be expensive just to slow down attackers who are trying to brute force their way in. Again, some things we aren't going to talk about today are how to deal with actual intrusion detection, network penetration prevention, and all sorts of other firewall access and logging and fail-to-ban and server-level protections you can put on the machine. Those are the things you should look into, but that is like another 2.5-hour workshop to go into all of that. Next, as I said, we need account recovery. Account recovery is what happens when somebody forgets their password. They put down a super secure password that's like 90 characters, alphanumeric, with a bunch of special symbols, and they knew, I will remember this with a handy mnemonic, it'll be fine, and then the next morning, I can't remember what it is. So you need to be able to recover an account. Since we're using emails for usernames, accounts should be recoverable by email, because those are the two pieces of information we have, a hashed password and an email. So if you forgot your password, provide your email, we can recover your account. Definitely helps when users forget. Recovering an account via email can also power magic link style logins. Who here uses Slack? I know there's a Slack team for PHP World. Slack gives you the ability to use a magic link, where instead of typing a password, you get an email in your inbox, you click a link, you're now logged in. There are some problems with that, which we'll get into when we talk about two-factor authentication. But once you do have a password recovery mechanism where you can recover via email, you have the rudimentary foundations of a magic link authentication scheme. Very good example of this, my wife uses a bunch of different statistical tools, uses incredibly long passwords, everything is incredibly secure. Every time she uses it, they say your password is going to expire in like 20 days, so you're going to have to change it again. She never does. She just goes back and says, I forgot my password, gets a link in her inbox, logs back into the account, sets another random password. It's really efficient for her, kind of laughable that their security allows it, but all of her passwords, she just hammers on the keyboard until it's done and everything's been fine. What was that? Never needs to know what it is. But again, and we'll get into a little bit more about the magic link style, why it can be weak. Remember, if anybody can intercept your email, they can have access to your account. So we need a way to protect password recovery from a third party stealing our email address or somehow finding their way into our inbox. Because if you can use a magic link to authenticate, your account now is only as secure as your email address. Not requiring the password improves the user experience. People don't have to remember a password. And no passwords means if your database is ever breached, even if you were using an insecure password scheme, if you have no passwords in your database to begin with, there's nothing for an attacker to actually pilfer and use. So Yahoo could have benefited from this. LinkedIn could have benefited from this. Apparently, I had a MySpace account or something like that, and I got hit the other day with somebody saying, we know your MySpace password. I'm like, great, I didn't even realize I had an account. Multi-factor authentication is another thing that we're going to work on. Remember, usernames are identification. They're something you are. Who here has an iPhone? Who has used Face ID to log into their iPhone? Thank you. Thank you so much. If your username is stolen, you can potentially change it. If your email is stolen, you can potentially change it. If your face is stolen, I hope you know a good plastic surgeon, because now anybody who has your biometric information can log into your device. Or your fingerprints. Identification is not authorization. Identifying a username is not authenticating you to a system. Identifying a fingerprint does not authenticate you to your phone. It identifies you. Passwords are a first form of authentication. They're something you know and something that can be changed if it is ever breached. Secret information that you know and that you can prove your knowledge of to the server, either by providing it so the server can calculate a hash or by using it to derive some other proof of work that you can then submit to the server to prove you do know this information. A two-factor authentication device is something you have. Once again, it can help prove that you have access to a certain piece of information or a certain secret. If you use Google Authenticator or Apple's Authenticator or Microsoft Authenticator, there is a secret key stored on your device that is used to generate a time-based token you provide to the server the server can validate that that time-based token is accurate and also matches your secret key. So you have the trifecta, something you are, something you know, something you have, multiple factors helping you authenticate rather than just a single password. Even if your password is leaked, having multi-factor authentication, having two-factor authentication will prevent anybody from breaking into the system. Even if somebody were to steal your email account and send a password reset link, if you're using two-factor authentication, that password reset link is completely useless to them because they cannot prove that they are you because they do not have your device. If you use magic links, like Slack, the something you know disappears. You don't have to ever remember a password. And the second factor, a Google device, a YubiKey or something like that, is the additional factor that keeps you secure and allows you to log in without actually losing any security. Slack allows two-factor authentication, but it's opt-in, and you have to go through like 3 menu settings to find it, so nobody ever uses it. They also do it via SMS a lot of times instead of TOTP. Come back tomorrow at 3 to understand why that's a bad idea. I actually have a video demo, so that one will be cool. Finally, let's talk about push notifications. Push notifications also give you the something you have two-factor approach because it has to communicate with your smartphone, with your device. In addition to that, it can leverage the software on the device and the hardware on the device to authenticate more strongly. If you get an SMS on your phone, it's a 6 or an 8-digit code that you type in. If you use Google Authenticator, it's a 6-digit code that you type in. If you use push notifications, you can have a 2000-bit RSA key on your phone, which you couldn't write down and remember if you wanted to, and that can help you actually authenticate. Plus, both iOS and Android, Apple and Google, have secure storage on the device where you cannot remove the private key. Once the key is created, it cannot be extracted. You don't have an ability to concretely authenticate somebody has possession of a certain device by sending them a push notification that has to be challenged in a challenge response flow. The server sends a challenge, the device signs the challenge, returns the signature. You have now proven that a user has something in their possession. It also leverages out-of-band communication, which makes it trickier for a third party to intercept or kind of like infiltrate. If you're dealing with just email, you've got one band, one method of communication. If you're dealing with just a password being entered into a web page, it's easy for somebody to man-in-the-middle attack with a Wi-Fi pineapple and steal that password. If you're using a combination of direct entry of data into a web page, and you now need to receive a push notification via a completely different method of communication to a separate device, there are multiple moving pieces, and it is much more difficult for a third party to inject themselves into the communication flow and steal your information. So that was a lot of information about security, and we're going to go over how to implement almost all of this. So does anybody have any questions about any of that material thus far? Cool. So this is going to be our first break. This one could be 5 minutes, could be 10 minutes. It's going to be as long as it takes for everybody to get set up. 2 things that you're going to want to do. The first one is clone a repository in GitHub, PHP security tut tutorial. This is the project we're going to be working on today. The second thing, and this is completely optional. If you have Docker already set up, maybe pull this mail catcher Docker image, because when we start doing the email verification, like account recovery, being able to send yourself an email without talking to the network is useful. If you don't have Docker on your machine, do not download Docker right now, because that'll kill the Wi-Fi, and we don't want to do that. But if you have Docker already, feel free to pull this image. If you don't have Docker and you don't have a way to intercept emails on your local machine, we'll figure it out as we work through the code. That's fine. But let's go ahead and take a few minutes. Like I said, get this Git repository. I have the vendor directory is checked into the code repository, so you don't have to clone anything else. You don't have to download anything else. It's quite literally just cloned as Git repo. If anybody's having issues with it, I do have 2 USB drives up here that already have it copied to it, so you guys can grab it without having to go over the network. So I will go ahead and start in on what we're doing with the application first, and then we'll work on this interactively. If anybody has any problems or if anybody needs anything, go ahead and let me know. After we get through each one of the exercises we're working on, I will show you my approach at solving the problem, so you can actually, everything's tested, everything works. There is no necessarily one right answer, but we can get into the way you did it, the way I did it, and we can talk back and forth. So the first thing we're going to do is deal with usernames and passwords. The application itself already has login and registration built into it. Passwords, however, are not being stored or validated. The application is using a flat file database called Flintstone, just to make life easier, so everything is stored as serialized documents in the file system. But when you register, the password is completely ignored. Registration will make sure that your password and your confirmed password match, but it won't actually do anything with it. It just completely ignores it. Likewise, login, if you have an account, you can type your email address and any password you want, and it ignores the password. It just makes sure that you gave it a password, and it'll allow you to log in. We want to fix that because that is obviously a massive security hole. We want passwords that are stored on registration. We want them stored securely, so we want to hash them. We want users to be able to change their passwords. There is also a profile edit screen inside the application. You can change your password in the profile edit screen, but it won't actually do anything because nothing is actually writing at the moment. We also want to make sure that all passwords are hashed. We don't want to store anything in plain text. We also want to verify the passwords are the same password that was stored, once again using a constant time comparison. And I will get into later why we want a constant time comparison. Just know we want constant time comparison for now. Some things that PHP already does that help us out. The first one is a function called password hash, which is really cool. It takes in a password and an algorithm. We can just use password default. It's a constant in PHP, all uppercase, password underscore default as the default password hash. You can also use password bcrypt if you want to. You can also define your own constants if you want to, but we're just going to use password default. Depending on the environment you're working in, you can also add additional options that change the complexity of the hash and increase the work factor, decrease the work factor depending on your hardware. We're not going to get into that. We just want to make sure things are hashed and they are using a secure hashing algorithm. Like password hash, PHP exposes a function called password verify. This one is really efficient. It takes in the plain text password that you want to verify and the hash that you got from password hash. The string that you get out of password hash has the algorithm, everything it needs to for password verify to verify a password. These two functions right here would have saved Equifax 145 million of exposed customer data. So there's a lot of stuff that you can do with password hashing to protect your application, protect your system, protect your customers. These are the two functions that we need to deal with. When people talk about hashing, they also talk about salts. Password hash will set the salt for you. You do not have to provide your own salt. You can provide your own salt if you want to, but password hash already uses a strong source of randomness, so don't try to overthink the compiler and provide your own. Sometimes there are reasons you might want to provide your own salt. One of the reasons why we have so many different functions called rand in PHP is because older random number generators in PHP were deterministic. If you gave it the same initial value, it would generate the same string of random numbers every single time, which is not random at all. When the Zend group wanted to fix this and correct that problem, they got pushback from several enterprise customers who were using the deterministic nature of the random number generator to actually control data in their database. And when they said, we're going to make it actually random, they freaked out because they needed it to not be random. So that's why we have rand, mtrand, and all sorts of other stuff in PHP, because people were doing very bad things with random numbers. It's very easy to do bad things with random numbers. Salts are supposed to be random and unpredictable, so don't try to do it yourself. Just let the function do it for you. When you hash the password, no plain text is stored, just the salt, a flag explaining what algorithm was used, and the hash that was resulting. And that's why you pass the same string back into password verify, so password verify knows what algorithm was used, it knows what the salt was, and it can regenerate the hash and then tell you true or false, did the hash match. The verification routine does it securely. You don't have to do anything else. And password hash or password verify is constant time. So you don't have to worry about timing attacks, which again, I keep mentioning this, we will be coming back to that because account recovery is very susceptible to timing attacks. So right now, this is all we need. The code itself, I'll give you a quick overview of some parts of it. If I can find. Who here has used the Slim framework before? Who has never used the Slim framework before? Okay. Slim is my favorite framework for building PHP applications quickly. Can't quite see over here on the left, but you have a public directory with an index.php. This is just the common entry point of the application. There is a source directory which has dependencies, middleware, routes, and settings. And then there is a templates directory which has the dynamic templating for the application as well. The parts that we need to care about the most are in source. Most of the stuff in templates is already done for you. You don't need to worry about that. That's just the incredibly sophisticated design layout of the login page, which is just like the epitome of web design. That's all controlled within the templates directory. And I spent tireless hours coming up with this design. So it's fantastic. But the application itself, so this is the main entry point, which says that we're typically going to be using the CLI server in PHP. That's why we run Composer Start, which uses PHP's built-in server, so you don't have to use Apache or Nginx or anything else. We're going to load our Composer dependencies. We're going to use sessions in PHP to actually manage persistent state between requests. And then we're going to load our settings. We're going to load dependencies, load middleware, load our routing, and then run the app. Going through each one of these just to give an idea of what they are. Settings is just some flags for Slim. So we have a logger that we're going to be using, monologue, just to log all of the traffic that we need to. We have a renderer, which is going to be pulling our data from templates, and we want to have error details displayed. That's basically it. The routes is the core of the application, and this is how we determine what code is going to respond to what pattern. So if you do a GET request to just the base, just the home URL, there's some boilerplate here to handle any errors that are affixed as query variables, any messages that are affixed as query variables, and then render the index view. So take this index.php and actually load it. This is all code that you now have on your machine, so you can follow along if you want. Just giving you a quick overview of some of the different elements here. We have a register function. If you get the registration endpoint, it'll display any errors that might have occurred, and then it'll render the view. Posting to the register endpoint, however, will actually register a user. So this is one of the things where we said that we need to actually deal with something. We have the user's first name. Let me show you the registration form just for some context. If you want to create an account, we collect a first name, last name, email address, password, and confirm the password. That's it. So you can see over here, we have first name, last name, email address, password, confirm the password. If the email is empty or if it's invalid, so it's not an actual email address, we're going to redirect back to the registration screen with an error to tell the user they screwed up. They need to use an actual email address. Likewise, if that email is already registered, we're going to return back to the registration page and say you can't steal somebody else's account. And if the password does not match the password confirmation, we redirect and say that the passwords didn't match. In this case, we're using hash equals, which is similar to password verify. It is a constant time string comparison function. Repeating that again because it will come up again and be very important in a few minutes. But once all of these different checks proceed, we create our user array. We're going to keep track of the user's email. We're going to give them some random balance of RNG coin because that fits really well with the concept of RNG coin. We're going to keep track of their first name and their last name. And we're going to zero out the password because we haven't hashed the password yet. So I have a to-do flagged here to basically prompt you what should we actually do to verify this password. That's what we need to take care of for registration. The next route we have is login, which doesn't do anything. There's nothing in this function, and that's because it is deferring to a piece of middleware in Slim called password authentication. So that's where I'm going to come in here to the middleware and show you the password authentication middleware. When it is invoked, it's going to check an email and a password. It's going to make sure that they're both non-empty. because if you submit a username with no password or a password with no username, you shouldn't be able to authenticate. So they both have to be non-empty. If either one is empty, we redirect with an error and say you can't log in. Once we do have an email address and a password, we try to find our user in our users database. We are converting all of the email addresses to hex just because Flintstone has trouble with special characters like @ So converting it to hex for a key. Once we have our user, we can delete this debugging message. Once we have our user, we need to make sure that the password provided during login matches the stored hash word in the database. If they match, great. If not, move on and set an invalid login message. So here we have user data. So we decode the user, which, remember, goes back to this array. So now we have a PHP array with email, balance, first name, last name, and password. And we need to figure out what we're doing to validate the password hash. So if the password is valid, then we set their email address in a PHP session, and then we redirect to the dashboard, because now they're logged in. That is what we need to do for password hashing for login and registration. That might be enough to get started here. The last part, because we want users to be able to change their password. So we come down to profile, because there is a profile screen. Get on a profile screen will extract your first name, last name, and email from your user account and display them on the profile page. Posting to the profile, so I want to change my profile. I want to change my first name. I want to change my last name. I want to change my email. I want to change my password. You again have to confirm your password, just like you do during registration. And again, we want to update the user with a new hash of the new password. So all of these things are marked explicitly with to-dos. So we have the routes file and the middlewares file that have these to-dos. And that is our first exercise, is to figure out exactly what code needs to go where to actually power authentication. Now, those of you who can't actually run this, I'm more than happy to sit down and walk through where the code needs to go. But just go ahead and take your best stab knowing that we have password hash and password verify and where they would need to go. And then there's a trick in the Git repository which will show you where the code is supposed to go later. So we'll deal with that in a couple of minutes. So right now, we want to store the hash on registration, verify it on login, and as a bonus, be able to change it in the profile. It will take about 15 minutes for this. See how things go. Throw something at me if you guys need help. All right, and we've got a lot of work left to cover, so I'm going to go through my implementation for each of these. And if anybody else had a different approach, we can talk about that as well. So upon registration, where we had before what should happen here with the password, instead of just saying we're not going to store anything, we use password hash to hash the user-supplied password using the default password algorithm. So hashing a password is quite literally that easy in PHP. And it gives you pretty sane defaults. Once again, you can add options to this, so you can actually increase the work factor if you want to. So here is the password hash description as far as the documentation goes. So you have the password, you have an algorithm, which we use password default. Then you have options, which will give you, once again, you can supply a salt, or you can just supply a work factor. The default work factor is something like 8. But if you're dealing with, if you think that you're being hacked by North Korea or something, you could increase the work factor and make your passwords even harder to hash. Typically, that's not something that most of us will have to worry about with our users. And if anybody does have to worry about that, let me know, because I can change my advice accordingly. So that is what you need to do to hash a password. Verifying the password, which happens in the middleware, is, once again, is very similar. You use password verify. We pass in the user-supplied password on login, and then we pass in the stored hash that we got back out of our user data. And password verify can split that hash up into the algorithm, the hash itself, and the salt, and then verify that hash. If it returns true, that password matches that hash. It returns false, they don't match, and we should reject the authentication. The last part was how do we deal with when users want to change their password. So we're going to process profile updates. We're getting their password confirmation. We're still doing hash equals to make sure that the password and the confirmation password match. And then once again, we just use password hash. I always feel guilty when I say that it's really straightforward to hash passwords in PHP because we did not have password hash and password verify until recently. Older versions of PHP, like PHP 5.2, which is the default for WordPress, do not have that. So they have to include entire other libraries to actually deal with things, which is also why they're still using MD5 to hash passwords, because they're trying to support legacy platforms. I hope nobody has to support legacy platforms like that, because these tools are so much easier. It is so much more concise to write two functions than it is to include like the PHP pass or PHPass hashing framework, which is a very large application in order just to hash passwords. So does anyone have any questions about password hashing, password verification? Cool. The next component is very similar, which is account recovery, because now that we're storing passwords and we're hashing the stored passwords, if a user calls up and says, I forgot my password, we can't give them a password. So we need a way that they can reset passwords on their own. This usually means we're going to send them an email with some sort of a reset link, some sort of a token that they can use to reclaim access to their account. Let me say that again. The link is a token that anyone can use to claim complete and total access over the account, which means it is just as powerful as the user's password. There are also some other things with this token. Unlike a password, the token's typically not hashed, which means you can actually leverage a timing attack, which we will go into in detail on the next slide. So for security with our tokens, we're going to leverage what's called a split token approach, which I'll describe as we talk about this timing attack. A split token is typically 32 random bytes, which works out to 64 characters. The first half is used as a lookup. It's used as an index. You query the database for this lookup. The second half is hashed and stored as the verifier. The user, when they click on the link, they're providing both halves in that one token. The database only has one half, so you can't actually guess the second half. Validation retrieves the stored hash, compares it with the hash of the hash verifier. And this sounds a lot like what we just did with usernames and passwords. It's exactly what we just did with usernames and passwords, except usernames and passwords, the email address is the lookup, the password is the verifier. In this case, we have a single string where half of it is the lookup, half of it is the verifier. And now I'm going to explain why timing safe comparisons are so important. Let's say your secret token is this is my key, and you're just trying to use double equals, triple equals in PHP to actually do the comparison. This is an approach I see in far too many PHP applications because it feels like it's going to be safe. It feels like it's going to work. We're using the triple equals, which is equality. We want to verify, are these two strings exactly equal? The problem is how this is actually implemented under the hood. Here's some C code that you're probably never going to have to write, I hope, which is how PHP actually does this under the hood when it's trying to compare two strings for equality. The first thing it checks is to see if the first string and the second string are actually pointers to the same value in memory. If they are, it returns yes, these are identical because they are the exact same area in memory. Chances are good you're not passing the exact same variable in on both sides of the equal sign, so they're not going to be a reference to the same memory spot. So we end up in the second part of the conditional. Now it's going to check and see, are the two strings the same length? If the two strings are the same length, then it continues. If the two strings are not the same length, so remember we started with this is my key. If get secret is A, it immediately exits. It doesn't even bother comparing anything else. It just immediately exits. If they are the same length, then it comes down here and it does a comparison of the two strings, one character at a time. This is my key. If you supply applesauce or something, it'll look at the first two characters. Are these first two characters the same? No. Reject. It doesn't even look at the second half of the key, or the second half of the string. If they are the same, then it says, great, now it moves on to the second character. Are these two characters the same? If they are, great, moves on to the third. And as soon as it detects a difference, it returns and says these two strings are not the same. If you're doing a single comparison of a single string to a single string, this is really fast, you're not going to notice a difference. But if you have a persistent attacker who is trying to brute force their way in, you can get some timing information out of this. Because if the two strings are not at all alike, it's going to return faster, slightly by like a millisecond, than if the first two characters are the same. So if you have a system that you are attacking, you can spam it with a bunch of traffic, track all of the returns. The ones that are the slowest are the ones that are closest to the target string. Not going to go into the full details of this attack. It is actually a practical attack. We use a token-based email reset mechanism in our own software. We were red team in our own software, and I actually wrote a JavaScript application that was able to extract tokens using this exact timing attack against our production system, which we then fixed 3 hours later because we didn't want anybody else to deal with that. So this is why we use split tokens. Remember, a split token, 64 characters. The first 32 is stored as the lookup. The second 32 is the verifier. You can always still leverage a timing attack against the lookup because the database is doing this at the same time. It uses the same mimcomp. It uses the same character-by-character comparison to find that. So you can still timing attack the first half of a token. The second half is hashed with a timing-safe comparison. Doesn't matter how many times you hit it, it's always going to return in the same amount of time. You're not leaking any information. By splitting your token into two pieces, you end up having a more secure system where people can't leverage a timing attack against your platform and steal access to someone's account. Does that all make sense? Does any of that not make sense? Does anyone have any questions? Yeah. You're generating that right now. This is the exercise. So I will show you the parts in the code where that is going to need to live. So we have, you come in here, I don't want to say that password, and I log out. I say, oh no, I forgot my password. I want to be able to give it my email address and say, reset my account. So that's what we want to do. So we need to have a handler on the recovery endpoint. So we come in here to process an account recovery action. I already built that, never mind. Or did I? I think I already built most of that. Yeah, I already built most of that. So you're going to have like a recovery action inside your code, which I don't know why I did it there. But if you check out the authentication branch in the repository that you have, it has all of the code for actually dealing with password hashing already implemented. Unfortunately, it looks like it also has dealing with this reset token, which I guess we'll just talk through it because the time-based one-time password is going to take a long time anyway. So what we're going to do is we're going to create a reset token for the user. So in this case, we're going to use random bytes, which may or may not work for those of you on PHP 5.6. Random bytes actually uses the random number generator built into the computer, built into the machine, to give us 32 random bytes. We're going to immediately hex encode them, which expands the 32 bytes into 64 characters. Then we're going to split it into two chunks. The first 32 character chunk is the lookup. The second 32 character chunk is the verifier. That's the one that we're actually going to hash. We're then going to set in our tokens database, the lookup is the key, and we're going to set a password hash of the verifier using the default password, the user's email, and the current time that we're actually creating this. Anybody have an idea why we're including the email and the time? time so you can time it out. Email so that we can identify the user later when they come back. Once we have all of this in place, and this is why running it on 8080 versus 8090. So we're going to create our link as localhost 8080/reset with token equal to this token. I'm using PHP mailer, which is bundled with Composer in the dependencies for the project, to build an SMTP email that uses really super secure SMTP authentication of admin and secret to localhost to send an email. Is going to be coming from admin@rngcoin.com. We're going to set our recipient to be the email recipient that we want it to be. We're setting it to be an HTML message with the subject, reset your RNG coin password. Click this link to reset your password with the reset link, and then a text body in case you don't have HTML mail set up. That's basically all there is to it, to actually sending the password reset link. And let me show you what that looks like, because the Docker file, or the Docker image that we downloaded, gives us the ability to capture messages that come through. So let me clear all messages. So when we're saying talk to localhost on port 1025, that is talking to this Mailcatcher app. So if you wanted to talk directly to Mailcatcher, there we go. So I have this Mailcatcher app listening on ports 1025 and 1080. 1025 is just the default SMTP port for the Docker image. 1080 is for the web interface, so we can actually see what it's doing. If you wanted to run this yourself, you would do docker run -d name demo p 1080 1080 1025 1025, and then the name, the Chickling Mailcatcher. If I were to, that is basically the exact same command that I ran to actually create this one that's currently running. But those of you now have this image on your desktop. If you wanted to run the same thing, so you have Mailcatcher running locally, this is the Docker command you would use to run it, and it's going to bind those two ports. Note of caution, if you are on the hotel Wi-Fi, this means ports 1080 and 1025 will now be visible to every other computer on the hotel Wi-Fi. And other people might try to send bogus emails to your Mailcatcher app. Keep that in mind. Make sure you shut the images down after you're done, because this is exposing them. It is wiring port 108080 inside the Docker container to 108080 or 1080 on your machine, which will likely be exposed to anybody. For example, I ran a test on another computer, and sure enough, I could see Mailcatcher running on my computer on the Wi-Fi sitting in the developer lounge. I also found out lots of other people are running development environments on their machines and exposing ports 80 and 443 to the entire conference. So make sure you turn stuff off when you're not using it. But that is how we run Mailcatcher. And to show you an idea of what this will look like, so we currently have no messages in here. We're going to come in here and say, reset my password, check your email. Hey, look, I have a message from admin@rngcoin.com. Reset your RNG coin password. Click this link to reset your password, and that link is to /reset ? Token with, can't really see it because it's small, but with, you have a, I don't have, there we go. You have a long token here for the actual token that's being used. And inside the database, we have our tokens.dat file, which shows this last token. Here's the lookup. Here's the hashed verifier. Here's the account that I issued it for. And here is the time I issued it at. So now we have this token that's available. The database has it. We could, if we wanted to, script a timing attack, but once again, we're only ever going to be able to use the timing attack to exploit the lookup. We aren't going to be able to reproduce the other 16 bytes that are used as the verifier. And 16 bytes, even though 16 feels small, is a lot of entropy in order to attack. You were very right. Keeping track of the time is so that we can expire the token. Right now, I think I set the tokens to expire in 10 minutes or something like that. Depending on the system, you might want them expiring longer or shorter. I've worked with some companies who say they want tokens to be valid for 30 seconds, and one company that said they wanted tokens to be valid for 24 hours. That last one was not a very secure client. So that is the main route for generating the token. Now we want to process an incoming token. So like I said, it was the /reset handler. And we're going to get the query parameter token. Once again, we're going to split the token the customer has provided us into two components, the lookup and the verifier. And then we use our handy function password verify. After getting a token from the database, we use password verify to pass the verifier the user just supplied in, as well as the actual hash password, or hashed verifier. We also want to verify that the token is less than 15 minutes old. If the token is older than that, we just want to abort. We don't want it to be valid anymore. If it's less than 15 minutes old, that's great. We're going to go ahead and use that. Once again, this is saying token data 2 was the time. If everything is valid, token data 1, the user's email address, we use that to fetch the user account from the system. And if that user exists, we're going to log them in and actually redirect them back to, in this case, the profile rather than the dashboard, with a prompt to say they might want to reset their password because they just used the password reset mechanism. So if I click on this link, it'll come in here to the application, automatically logs me in, takes me to the profile page. Did anybody have any questions about how that worked? Does anybody see any red flags in how that worked? Maybe go back to the fact that anybody inside this building can currently send messages to port 108080 on my machine. Did anybody see any problems with the fact that I was able to click on a link and I now have the ability to change my password? Didn't ask me for anything. Everything is there. This is how the magic link functionality works in Slack, Capital One, Chase, and several other secure organizations where you can say, send me a magic link, and they give you a link that you click it. They don't ask you for any other information. They just say, send me a link, and now you have access to your account. So let's go ahead and fix that. And this one is going to take a while. So first, let's take a 2-minute break, just in case anybody needs to stand up and stretch. We've got a little bit more than an hour left, and it's going to take that long to actually walk through OTPs and push notifications. So 2 minutes. We'll start again at 4:20. OK, let's talk a bit about multi-factor authentication. We're specifically going to talk about 2-factor authentication. You could have 3 factors, 4 factors, how many factors you want. The point is adding a second or a third or any other factor other than just a password increases your security, makes everything a little bit safer. There are several different options for multi-factor authentication. I use all of these, but let's talk about each one in turn. The first one is some sort of a hardware token. This might be a YubiKey. Has anybody here not heard of YubiKey? Cool. Kind of. It uses RSA. So for example, this is my YubiKey. It's got a strong RSA key on there, which I can use with GPG and SSH to do authentication, but it also features some other functionality where, like when I log into GitHub, it will say, touch your security key. And then this thing is touch sensitive, and you tap it, and it generates a challenge response with GitHub to actually authenticate, yes, I am me, and I do have this in my possession. You can also use a code generator, which would be that they have hardware code generators, software code generators, all sorts of different code generators. YubiKey will work as a code generator. You can use a mobile phone with an authentication app, like a Google Authenticator. Today, we're going to talk specifically about TOTP, time-based one-time passwords, And we're going to talk about using an authenticator app. That's why I recommended Google Authenticator and asked if anybody didn't have one. So let's talk a little bit about what TOTP is. TOTP uses a secret key that is shared between the mobile device and the server. So both of you have access to the key. There is a little bit of onboarding to actually get that key into the phone or get that key into the server. We'll talk about that later. There is a piece of secret information that both you and the server have. The key is used inside an app like Google Authenticator to hash the current time and generate a 6-digit code. This is based on HOTP, which is HMAC-based one-time password, where you use a counter. So you have code 1, code 2, code 3, code 4, and you hash that counter 1, 2, 3, or 4 with your HMAC key and generate a token. Google Authenticator takes the Unix timestamp and uses that instead. The server, because it also has a clock, can generate the same code independently. It knows your HMAC key, it knows the current time, and you'll also give it a little bit of wiggle. In my implementation, I usually go 2 minutes on either side because Google Authenticator and other authenticator apps will automatically increment every 30 seconds. And sometimes there's drift between the systems, so you want to be able to account for drift. If your computer is maybe 45 seconds behind the server, you don't want to have an authentication error because you can't actually verify the same code. We still need to use constant time comparison because, once again, you are comparing a string. So we're still going to use hash equals, which will not just compare every letter at a time, it will compare every letter at a time whether they match or not, and walk its way entirely through the string of 6 random numbers. Users should always be prompted upon login, whether they are providing their password or clicking a password reset link. They should always be prompted to present this second factor of authentication and prove that they are who they say they are. Let's talk about some places how you would set this up. User profile page, which is where we change the password, should allow you to enroll with a random key. In our case, we aren't going to use a QR code just because QR codes are kind of messy. We're just going to print the code to the screen. We're going to make the code already available. It just needs to be set up. Logging in. Why did I say that? Oh, yes. When you log in, you shouldn't be logged in immediately once you provide your password. You should provide your username and password and click login, and then have to provide a 2-factor authentication code before you're actually signed all the way in. Who here likes ads on news sites, Facebook, social posts, likes to see advertising all the time? Who here uses an ad blocker to block that advertising? Who has seen the fun interstitial modal windows that will pop up and say, we see you're using an ad blocker. Please disable ads or pay us $4.99 a month. I have code in all of my browsers that remove those interstitial ads because all of the content is still there. They just put an overlay on top of it and say, we don't want you to see this unless you're paying. But all of the content is still there. Likewise, I have seen implementations where someone will log in with the username and password, and then they will be logged into the application and get a pop-up saying, please confirm with your second factor of authentication. Just like trying to have an ad blocker, that is not adding security. If you are in any way logged into an authenticated session without providing a second factor of authentication, you are vulnerable to somebody being able to steal your account. Logging in should always delay that full authentication. You can do that with another form of session management, set up a temporary session that only allows for providing a key but doesn't actually give account access. It doesn't really matter. The point is just you must require that second factor. So we could add an interstitial confirmation screen before the dashboard in our application. In my implementation, I think I just added a second field. So you have to provide your username, your password, and a 2-factor authentication code rather than inserting a second interstitial. You could also switch behavior based on the presence of a 2-factor authentication device. You don't need to. You could just say everybody has to have 2-factor authentication. It's up to you. The exercise now is to actually add 2-factor authentication. And I realize I have not given you nearly enough to go on to add 2-factor authentication. So instead, we're going to work through this interactively as we go through this. I encourage you to work along alongside this, but there is a lot of code that actually goes into a two-factor authentication implementation, especially with TOTP. The advantage is the specification for this is a published document that is completely open source, and it has a base implementation in the spec. It literally says, this is the security feature we want, and by the way, we already wrote the code to implement it. You just have to copy it into your application, which is really cool if you're actually working with it. Likewise, I have already built most of it. So go in here. And I'm cheating because I have different branches. So now I'm on a TOTP branch, which you all have as well. And if I come in here now, so I'm still on the profile, I'm still logged in, you can see I have a TOTP key. Everybody write this down really quick so you can log into my super secure random number generator Bitcoin clone. This TOTP key I have also embedded in my Google Authenticator. Which I can't zoom in on this. But down at the bottom, I have an app called RNG. When you are working with Google Authenticator, you can enter an account just by specifying an account name and a TOTP key. So in this case, you would be saying this is PHP World Demo, doesn't really matter, and then you would manually type that key into the phone to actually make it so you can authenticate. You can then ask it if you want it to be timer-based or counter-based. We want it to be timer-based because we're going to be working based on a clock. Does this part make sense so far before we move on? Cool. So if I go back to the dashboard, and man, look at my RNG coin. This is just so awesome. Oh, look, it's going up. That's so great. I can retire on all of my fake Bitcoin. That's so great. You guys don't know how cool it is that you have this application now. I'm mining for my ICO right now. And once again, I said you're going to start with an email address, a password, and a 2FA code. So in this case, I will come in here, say I am me. I think my password was test. Can't remember. And now I have to come into Google Authenticator because if I just try to log in, it'll tell me invalid authentication. Instead, I want to then I will provide my super secret code of 570464. Nope, still invalid because obviously my password didn't work. So let me delete that account, create a new one. So create an account. Okay, so now I've created an account, and I need to register my new TOTP key. Remove RNG. This part I was really hoping I didn't have to do live, but LPO. You're all copying this down really quickly, right? S3. There we go. So I now have a new RNG. So I'll go back to the dashboard. Oh man, I lost all of that RNG coin. Sad. I'll log in again, but this time as Eric plus test. Once again, pull it off of Google Authenticator. It's going to be 30 seconds or up in a second. Hold on. I can't type that fast. Okay. 622013. Log in. Welcome, Eric. Current RNG. There we go. That was pretty simple. Once I had the right password, I could actually log in, but it wasn't leaking any information by just saying invalid credentials. It wasn't telling me it was an invalid code or an invalid password, because otherwise somebody might be able to guess the password or guess the code. So this way, we are secure. We're in there. RNG coin is going up, which is fantastic. We can retire soon. But let's go through the code that actually makes this happen. I'm saying that this is really complex because it is. I actually built this into a WordPress plugin a while ago to add this kind of two-factor authentication to WordPress. Not many people use it because I am such a good designer. They just can't put up with my design skills and they think it's too pretty, so nobody wants to use it. But it is available. It is open source, just like all of the rest of this code. So let's walk through what it would take to actually set this up. The first thing we're going to do is when we register a user, we have to register a TOTP key. So in this case, and we're going to be leveraging random bytes again. That's recovery, not register. So I really apologize for those of you who don't have random bytes available. You should totally upgrade to PHP 7. So we're going to run a function called generate key. So we're just adding a new value to our data store. So we still have the email. We still have a random balance between 0 and 10, first name, last name, hashed password rather than plain text password. Now we're going to generate a TOTP key. Remember, this is the HMAC that has to be stored between the server and the mobile device. Just like I had to type it all in by hand, you could present a QR code, which then the Google Authenticator app can scan the QR code, and you don't have to type that really long code. Generate key is a really well-documented function that generates key. It will generate a key of a certain bit size. So we want a key that is 128 bits, base 32 encoded. Who has ever used base 32 encoding before? Other than Chris. Base 32 is like base 64. Base 64 just has 32 more characters, so you end up with uppercase and lowercase and all of the numbers and a couple of special punctuation for base 64. We don't want any of that, so we just want base 32. So we're going to take whatever the key is that we're generating, the random key, and converting it to a string that only uses these 32 characters. Base 32 is a spec. It is specifically these characters and no other characters. 1 is specifically disallowed. Can anyone think of a reason why 1 might be disallowed? It looks like an L. Because here we're saying all uppercase just for consistency. Base 32 actually allows uppercase or lowercase, and you just cast everything to uppercase. So you can have a base 32 string that has lowercase characters. When you print it to the screen, a 1 and an L look the same, and it's confusing. So that's why 1 is not part of the base 32 spec, which is wonderful. What we're going to do is we go through our bit size. We're going to be using a default of 128 bits. Each bit is represented by a byte. 8 bits become a byte. So this is, what, 16 bytes? So 16 characters. For each byte, we're going to select a random character out of this base 32 character set. So we end up with 16 random characters. That's our key. Once we generate the key, we store it in our database. So you can see in my users.dat, this new user that I created with my super secure password also has a 16-character TOTP key. And then it's up to you to get that TOTP key into the device. The phone does a bunch of generation of the one-time password on its own. We need to verify all of that. So we're going to edit our middleware, which is our authentication middleware. And I'm scrolling past a bunch of stuff that I'm going to come back to. So when we invoke our authentication, we now have an email, and we have a password, and we have a 2FA code. All of our validation for the user email and the user password remains exactly the same. That doesn't change. We get our user. If we have our user, we decode their data, we verify the password. If the password works, now we're going to verify the authentication code. So we're going to run a function that we call isValidAuthCode with the user's TOTP key and the token, the six-digit token that they just provided. If it's valid, then they log in like normal. If it's not valid, we reject and just say there was a failure to authenticate. We don't tell them your username was invalid. We don't tell them the password was invalid. We don't tell them the code was invalid. So we're not leaking any information about the user. We just say, you screwed up. Try again. That's it. Now we get into the fun, super technical stuff. Is valid auth code? Like I said, it takes the HMAC key and it takes the auth code. We start with keeping track of the maximum number of ticks that we want to allow. A tick occurs every 30 seconds. We're using Unix timestamps, which are the number of seconds that have occurred since January 1st of 1970, and then we divide, can't remember what we would divide by, but we divide so that there is a tick. The clock increments once every 30 seconds. And we want to say a code is valid for up to 4 ticks after the clock is incremented. So for up to 2 minutes after the code is generated, the code is still valid. That way, if your phone is a little bit ahead of the server or vice versa, you can still log in without too much trouble. Some systems might want to change that allowance to make it more restrictive or less restrictive. It really depends on the situation you're working with. We're now going to create a range of ticks, 2 minutes on either side. So range is a cool PHP function that will create an array given 2 different values. So we're going to create a range of numbers from -4 to +4. -4, -3, -2, -1, 0, and everything. We're then going to sort all of those ticks into an array. Don't worry about this. It's just sorting by absolute value. So we start at 0, and then we try 1 and -1. Then we try 2 and -2, 3 and -3, 4 and -4. Because we don't want to try all of them. If we find out after like 1 tick the code is valid, we just want to authenticate. We don't need to authenticate everything. Timing safe comparison doesn't matter in tick generation, just in comparing the strings. So we're going to sort that using an absolute value sorting function, which we don't need to go into. It just sorts by absolute value. A tick, or the current tick, is time, Unix timestamp divided by 30. That was the number we divide by. Just, yeah. And then for every tick, we're going to go through and calculate what is the valid TOTP for that user, given their HMAC key, for that tick. Once we have that auth code, wow, I made a mistake. This should not be triple equals. That was dumb. That would have allowed a timing attack. I made a mistake. Nobody caught me. So in this case, we're going to check and see, is that calculated TOTP the same as the auth code that the user provided? And calc TOTP. This is where it gets into the fun stuff, where we actually start dealing with binary arithmetic, which is fantastic, which is why I did not say I'm going to have you guys do this on your own. So we're going to base64 decode the key. Once again, it's a 128-bit key. We're going to decode it back into random bytes. Base64 decode does all of that decoding for you, switches the bytes. Once again, make sure that everything's all uppercase, converts everything, and then we're doing bit shifts to actually move the buffer around, convert everything back into raw bits. If you understand this code, please explain it to me. It took me like 3 weeks to write, but it's messy. So we're going to go back to calculating our TOTP code. So once we base64 decoded our secret, the HMAC key, we're going to go through, figure out a bunch of steps, pack a timestamp into 64 bits, I think, and then we go through, actually calculate the HMAC, and then we convert the HMAC into a number based on all of this binary arithmetic calculations and everything. It's incredibly messy stuff, and I hate writing code that looks like this because it looks like Greek. But once we have that code, who here uses Node ever, like writes Node JavaScript? Do you remember the left pad fiasco a while ago? Those of you who don't remember, there was a developer who wrote a tool called left pad that specifically just padded characters to the left of a string. He had a disagreement with somebody else on Node about the copyright claim or the trademark claim on the name of a package he wrote. Node didn't contact him and just awarded control of the repo of the name to another organization. So he, in a fit of rage, deleted everything he'd ever published off of NPM. Several million packages relied on his left pad package, and they all suddenly crashed because nobody could remember how to add characters to the left of a string. PHP has a string pad function where you can pass in string pad left, so you don't have any external dependencies to left pad inside PHP. It is like the single biggest reason why everybody was saying PHP is better than JavaScript after that happened, because we have it natively and you don't have to install a third-party library. Just thought that was fun. So we're going to pad everything back because we need the code to be 6 digits, default of 6 digits long. Sometimes you'll get a code that starts with a 0. I actually had a code the other day where my actual TOTB code was 000055. And I looked at that, I'm like, that can't be right. So I waited 30 seconds till I went to the next one, then used the next one because I didn't trust anything that was 4 zeros. That just felt weird. But we want that because the user is going to be typing in 6 digits no matter what, and we need to pad to the left to make sure that it's valid. So once we have those TOTPs, we go through each TOTP. We do the verification. Once we find a TOTP that matches, now remember, we're calculating 9 TOTPs potentially for this user. 4, 3, 2, 1, 0, 1, 2, 3, 4. 9 TOTPs. Once we find one that matches, yes, they're authenticated. They're great. We can move on. We return true. If we go through all 9 of them and none of them matched, they screwed up. We return false. Everything moves on. Does that make sense? Does anybody have any questions about this? It was a very quick example, but all of this code is in the TOTP branch, so you have access to it. You can play with it. You can fix any mistakes I have with the binary arithmetic. It's fantastic. Let me know if my bit shifting was off. I was actually shifting the buffer in the wrong direction when I first wrote this. That was like a week of hitting my head against the wall. It did through 3 different levels of code review, actually. So the last thing that we're going to talk about is push-based authentication, which is just a different kind of multi-factor authentication. Like 2FA, like TOTP, it also leverages a secret key. The difference with push-based authentication is it's not a single HMAC key that is shared between the client and the server. Instead, it is an asymmetric key pair. The public key is stored on the server. The private key is stored on the mobile device. Once again, Apple has the secure enclave. Android has whatever it is they call their secure key store. They're both hardware solutions that will store the private key in a way that is incredibly difficult to remove and extract. I'm not going to say impossible because somebody actually did a demonstration where they used acid and like a really fine-tooth sander to actually get into the secure enclave on an old iPhone. It's possible. It's incredibly hard. If you're dealing with that level of attack, I'm not the person you want giving you the security advice. You probably need to go talk to your NSA handlers because they will give you much better advice. But we want to do push-based authentication leveraging this kind of security. This kind of security is great if you lock your phone. You're the only one who knows your PIN. Nobody else can impersonate you and verify your identity to the server. The server will send a challenge, a random string of bits, to the phone using a push notification. Apple's APNS, Apple Push Notification Services, Google Cloud Messaging, GCM, both of those can be wrapped with Amazon Simple Notification Service, SNS. Windows, I don't know what they're calling those right now, but they also have push notifications. You can do push notifications to every device, Chromebooks, even desktop computers. It's capable to actually get that push there. You push out the random string of bytes. The mobile device uses the private key stored in the secure enclave to sign that challenge and return that challenge back to the server. The server can then use the stored public key to verify the signature on the challenge and say, yes, you do have the device in your possession to sign this challenge. As we mentioned earlier, it's an out-of-band communication, so it's not typing into a web browser or looking at my phone and typing something in. It is a separate communication channel, typically your mobile network, possibly still over Wi-Fi, but it's an additional round trip, it's an additional mode of communication that can help further secure your application. It does require a significant amount of infrastructure setup. My Apple certificates expire in 3 weeks, and I'm terrified because I have to go through the wonderful hoop jumping of getting all of those recertified so that we can continue for another year. It's very tricky to set up, so we're not going to walk through the full setup of building a new system from scratch. I'm going to cheat and use my own system that already works, but all of the code, the PHP integration, is still useful to actually see how this executes. There are multiple providers that support push notification authentication. I'm going to use Tosney just because it's my employer. It's there, and I control the infrastructure, so it's really easy to work with. There's also LaunchKey, which is a product by iOvation, does the same thing. They also have a PHP SDK, just as easy to integrate. Auth0 also does push notifications, has an SDK, it's easy to integrate. Google Prompt allegedly has an SDK that is allegedly easy to integrate, but I haven't yet to find any conclusive documentation other than our SDK is easy, why can't you figure it out? So I'll demonstrate how this works. We're going to be using push as a second factor, but you can also use push to verify an action. Think about banking, which is the example I usually go to. You want to transfer $5, sure. $20, sure. You want to transfer $3,000 from one account to another. That's a red flag. Maybe we want to double check. You might have accidentally typed 3,000 and missed a dot when you were trying to type $30. Some banks will send push. Chase will send you a text message after the transfer has happened to say, oh yeah, by the way, you just completely drained your account. They don't proactively confirm the action. So we want to protect large actions, large purchases, with additional authorization. You can also use it to notify the user of changes or account modification. Unlike TOTP, this kind of verification is out of band. So you can use TOTP to say, hey, we want you to go through and generate a token and verify this transaction, but you're still asking the same person sitting in front of the computer who may or may not actually be the person. For example, we just had a web page loaded over HTTP presenting me with my token that I could type into my device on a projector screen in front of a room full of people taking notes. It'd be fairly easy for somebody to go through and call me in the middle of a presentation. It would be really easy for somebody to go through and steal that, sniff the traffic on Wireshark and figure out what that token is, sit in the back of the room and write it down on a piece of paper, and then spoof that. Because once you have that token, I could set up every single device in this room to generate the exact same TOTP as my phone, which is why a shared HMAC between the two is very difficult to secure. You can do it securely, but there are many more ways to accidentally breach that security with TOTP. With a push notification, it's out of band, private key never leaves the device, public key does leave the device, and it requires a separate communication method. It's not like with the system we have now, you could impersonate me and actually go in there and log in as me because you know that my password is test and you now have my device token. You do not have my push tokens, though. It's impossible for you to do that unless you physically have my phone because you cannot port that private key onto another device. You have to completely set everything up differently and re-enroll. So that is why push, unlike TOTP, is a better source of verification that you have the actual device you're supposed to have. One of my coworkers, whenever he sets up a TOTP token on his phone, he also screenshots the page and stores the screenshot in Dropbox so that if he falls into a pool and his phone dies, he can rescan the barcode and put the same HMAC onto his new device. Fantastic for him. He never has to set up two-factor auth again. Dropbox also scans all of your images, which means there are Dropbox engineers who have the ability to impersonate him in his AWS root account and access everything else that he does because they can see all of his images in his Dropbox folder. TOTP is great. It's not everything. Push gives you additional capabilities. The downside with push, your device has to be online. If your device is not online or network capable, there is no way for Apple or Google to push a notification to you. If you're traveling internationally and you're in airplane mode, you can't authenticate, which I learned the hard way because I completely forgot that I had everything set up that way. So you have to be on the Wi-Fi. That's also why I didn't expect anybody to go through the demo today because I don't trust the network and it might not actually work. So instead, we're going to go through a demonstration of how this actually works. And I'll show you all the code, once again, using the Tosni SDK. But there are other providers, and I am more than happy to help you get set up with those providers as well. So the first thing first, I'm going to check out a new branch called push. The middleware doesn't change at all. What is going to change, we have our dependencies. So our dependencies, I haven't really exposed this, but our dependencies keep changing on and on and on. So we started out with users, we have a coins database, we have tokens database, we have renderer and a logger. Now I'm adding a Tosni interface, which is going to use Tosni's remote realm API. In Tosni and different systems, you have one account that you use when you authenticate as an administrator, and you administrate multiple realms or sub-accounts. It's just a different way to partition things, because you might be managing your Office Fantasy Football League that all needs authentication and your DevOps team that all needs authentication. You don't want those two to mix. You never want those two to mix. So you keep everything as separate as possible, keep everything pulled apart. In this case, we're just initializing our Realm API and setting up a remote key and making sure that we can actually authenticate. Now, all of this code is currently in the repository that you have, so you can go through this. I do have some code inside settings, which is not, so I have like secret keys and things, which those are not in the Git repository. They were in a private stash that I had locally, so you don't get to have that. But we are going to go through our route, because this is going to change this route. Or yes, this is routes. So what we want to do is on our application, because it is RNG coin. I'm going to reload the dashboard just so I can get everything. So I currently have 7 RNG coin. I want to buy and sell RNG coin because I want to speculate. I mean, it's worth $1.19 right now. Who knows how much it'll be worth later? I mean, buy a sports car with this stuff at this current value. So I want to say, let's buy $1,000 worth of RNG coin. That would be great. But do I really want to do that, or is somebody trying to use a cross-site request forgery attack to trick me into buying RNG coin? Or worse, into selling my RNG coin and losing out on any midterm gains as it continues to go up to $1.20. I mean, look at this. This is fantastic. I love random number generators because this should be just a constant dollar, shouldn't it? It's just sources of randomness. So what we want to do is, instead of just authorizing this to go through, we want to get a push notification. So we're going to trigger a push notification using Tosni's existing infrastructure. So when you actually buy that, you're going to post. So this application, clicking go doesn't actually fire anything in PHP. I'll show you what the dashboard actually looks like in this wonderfully beautiful HTML fake PHP. So there is a JavaScript routine in here that is refreshing the value of the RNG coin every 5 seconds, just to see how things are going up. But we also, when you submit this transaction form, we want to execute an authorize function. Authorize is a JavaScript routine that gives us an alert just to say this is what we're doing. We're authorizing the transaction. It's going to get the information from the transaction, post it to a transact endpoint with our cookies, because we need our session cookie for authentication. It's going to take whatever response comes back, parse it as JSON. If there's an error, it's going to trigger the error. If it's not, it's going to start checking a session. Remember, this is an out-of-band communication. The server can't just post something and then wait for something to respond, because I might never click OK on my phone. I might not even get the push notification. Google and Apple both treat push notifications as a fire and forget mechanism. You call them and say, send a push to this user. They say, OK. That's literally it. They return just an OK. If it succeeds, they never tell you. If it fails, they never tell you. It is up to the user to tell you whether or not they received the push notification. So the application that receives it should call back to the server and say, yes, I received the push. The user didn't do anything. Because if they don't, you have no idea. Apple's not going to give you any status indicator. Google's not going to give you any status indicator. Amazon says, ask Apple or Google. So nobody wants to give you any help. So instead, when you issue a push notification, TOSNI will keep track of a session. Launch key will keep track of a session. Auth0 will keep track of a session. And then you can check that session. You can go back to the service provider and say, what is the status of this authentication request I asked you to dispatch? What is going on? If the user has not replied to the push, then the session is pending. And it just says, we don't know yet, hold tight. And you can continue to query this. What's the status now? We don't know yet, hang on. What's the status now? We still don't know yet. Once the user actually interacts with that push notification, the server tracks it. What's that status now? Oh, the user said OK. Now the application can go on and do that. So in this case, we have a check session routine that's going to continuously check the session with the server. So it's going to pass the session ID that comes back when we create this transaction, and it's going to, every 5 seconds, ask the server, what's the status of this session? If the server returns that session is still pending, okay, great, we're going to wait 5 seconds and then ask again. If it says that session is no longer, that push is no longer pending, it's going to say, okay, great, reload the page. Reloading the page refetches all of the data in the page and will refresh our balance automatically, assuming it went through. So this means we have to deal with a status endpoint and a transact endpoint on the server. So coming into our routes, the transaction endpoint is going to get 2 values, dollars in, coin out. How many dollars am I putting into the system to buy RNG coin? How many RNG coin am I putting up for sale? Yeah. Yes. I am asking for a valid response. What is going to happen is if I respond OK, then the server says, OK, great, update. If I respond no, the server won't update anything, but will still tell the JavaScript the session is closed, refresh the page. So until I respond, the session status is pending. Once I respond, whether it's OK or no, then the session is no longer pending and the page will automatically refresh. Inside, yeah. The JavaScript doesn't care. Yes. Yes. Yeah. So inside transact, we figure out what we're doing. Are we buying or are we selling? We get the user's data. We get the user's balance. We're going to do just a bunch of sanity checks. So if you're trying to sell more RNG coin than you actually have, it'll just reject it and say there was an error. You have insufficient funds. If you do have sufficient funds, then it's going to say, OK, we're going to take what balance we think you have, and we're going to deduct what you just sold. It's then going to say, now let's see what you buy. So we're going to figure out what is the current value of our coin. OK, let's add to your balance this many coin. It's really great. It doesn't actually hit a bank account. Isn't RNG coin fantastic? We can all speculate. It's awesome. Then for this user, because remember, we sent our session cookies, so we still have access to the session, we're going to set a value called new balance. Now this is the pending balance once the transaction goes through. If the transaction doesn't go through, nothing changes to your balance. You didn't buy anything, you didn't sell anything. But we will keep track of what your new balance will be, assuming you approve the transaction. And now we initiate a TOSNI challenge. And this is where TOSNI will send a push notification with the text, do you authorize a purchase or sale of RNG coin to a specific user who happens to be me? Hard-coded this value just to make life a little bit easier. The TOSNI challenge itself is going to, so the TOSNI challenge just creates a challenge. It doesn't actually contact anybody. It just creates a challenge on the server. And then you tell TOSNI later, now I want you to take this challenge and push it via push notification. You could also just prompt the user in the browser, do you wish to confirm this? and then tell Tosni, yes, the challenge was successful. You can do it however you want. Tosni, launch key, and auth0 will all allow you this challenge that comes back, in addition to including just the challenge, which is raw bytes, will have like a QR URL that you can display and then scan with a mobile device in order to sign it and complete the out-of-band verification. So in situations where you might be offline or in a place where you have limited connectivity, you can scan a QR code and conduct the challenge that way. It just gives you additional capabilities. In our case, we're assuming push is OK because people keep calling my phone. So we're assuming push is going to work because we assume the device is online. So we're going to push, once again, to my user with the ID of the challenge session, which just tells the service provider we want to contact this user and have them respond to a challenge. We then call that and write the response to the challenge back to the browser to JavaScript in JSON, which is what gives the JavaScript the ability to also extract the session ID and then repeatedly ask the server, what is the status of this session? And that is this other call here, where we ask the server, what is the status of this session? Which again, will use a different Tosni API. So instead of the Tosni Realm API, it will use the Tosni User API, which is unauthenticated. Anybody can query the API and say, what's the status of this session? Realm APIs have to be signed using that Realm secret, using a secret key. That way, they're authenticated. Realm calls are administrative calls where you can say, add a user, delete a user, change my billing account information. It's the kind of stuff you don't want to expose to JavaScript. The JavaScript could run this check status itself. It doesn't have to be in PHP. We're doing it in PHP here because we want the PHP to actually deal with the changes to the balance. So when it gets the status back, if the status is pending, it's just going to respond, the status is pending. If the status is completed, now if it's pending, it'll be pending. If it fails, it'll actually return an error, and none of this code will execute. If it is not pending, then it's going to actually go through, once again, get the user's new balance, set their balance to the new balance, update the user, attempt to refresh some stuff in the UI, and then just respond, we're done. Once again, if I don't confirm, it doesn't happen. If I do confirm, now it goes through and my balance is updated. So if I come in here and I say I want to buy 1 million RNG coin, or $1 million of RNG coin, click go. We'll send a push to your mobile device to confirm. Now let's see if live demos work. It did. So I now have a push notification from Tosni. Do you authorize a sale or purchase of RNG coin? And I can either confirm or cancel. If I click confirm, it says, there you go. It's confirmed. And the page refreshes, and I now own less than $1 million because RNG coin went down in value. So that is how you do push notifications. Once again, there is a lot of infrastructure setup that goes into that. You have to have the proper certificates in the proper places. In this case, it was a Google Cloud messaging platform. We also have Apple push notifications. LaunchKey does the same stuff. Auth0 does the same thing. Google and Facebook, I believe Facebook is doing this. All of the push notifications require an app from the service provider on your device. So to get a Tosni push, you have to have the Tosni app on your device. A LaunchKey push, you have to have the LaunchKey app on your device. Auth0, they've just published an SDK that you have to build into your own mobile app and put on your device. Google, because they have a bazillion different apps, if you have any Google app on your device, you can get a push notification from Google. So if anybody is seeing Google Prompt when you try to log into another Google service, just installing Google Search on your phone means you can receive push notifications from Google to log into Gmail on a different device. So you can actually use Google Prompt to have two-factor authentication for Gmail on your computer by way of push notification through your phone. So it gives you that added level of security, which we just did with our RNG coin. So if I come in here now and I want to sell everything, I will again, you'll get a push. Nothing happens until I come in here and I unlock my phone. Do you authorize a purchase or sale of RNG coin? OK. Now we're down to just 7 RNG coin, only $10 balance. So all of this was talking from my computer to a server to Google to my phone and back and forth. But again, I didn't have to touch my computer to do that. It was a separate mode of communication through my device to verify a transaction. This kind of security can be added to banking transactions. Are you sure you wish to delete this droplet? Notifications, which would have saved me a while ago. All sorts of different things you can add to different systems control, different authentication control, and it allows you to proactively add security to your system. I could have, yeah. Let's see. Yeah, so I will change that here too. Yeah, I will set message. And up here, I'll just set a default message. And then if we are buying coin, so here we go. Now I've got a default message. No, that's not going to work right there. So if we're buying coin, we want to prompt, are you sure you wish to buy a certain RNG coin? If you're not buying coin, just do you wish to authorize a sale? Not going to belabor that. So there we go. We have those two messages. I'll come back in here and I will purchase. Oh no, that's coin out. Do you wish to sell? Do you wish to authorize a purchase? Okay, so I will refresh this just to make sure I don't have any save state. And I will sell 3 RNG coin. Do you wish to sell 3 RNG coin? As you get the push notification comes through. So click OK. And there we go. I sold the 3 RNG coin. So all of the different push notifications are completely customizable. You can have whatever templates you want. Banking can say, are you sure you wanted to authorize a transfer of $3,000 to building PHP securely or whatever? Yeah, you can have any kind of message you want, verify things. Are you sure you, like if you're using it for authentication, are you sure you wish to log into Gmail versus are you sure you wish to log into the nuclear missile control system would be really useful for differentiating what is going to happen when I press OK. Provides a lot of context. And that is the gist of push notifications. So with that, my very delayed introduction. My name is Eric. I work for a company called Tosny. We do this kind of security, authentication, notification all the time. We also do encrypted databases, encrypted data storage to help keep private information out of your data store so that if you get hacked, you don't lose anything. And because of the way that we secure it, even if we get hacked, you don't lose anything. We try to make sure that nobody is ever at risk. We are sponsoring this event, so I will be at a booth in the lobby if anybody has any questions. All of the code is on GitHub for everything that we just walked through with the exception of my private keys. So everything is available. You all have copies of that. You can play with the code. If you find bugs in the code, feel free to let me know. All of the slides are already up on Speaker Deck. The talk is on Joined In. Please leave a rating, as well as with every other talk that you go to this week. Please leave a rating. Speakers depend on that. But now, because we still have about 10 minutes or so, does anybody have any questions or anything that you want to talk about as far as security goes? Yeah. that can be, lockouts after a certain number of failed attempts can also be somewhat hostile to your users because it can create an effective denial of service accounts. Let's say he has, after 3 login attempts, his account's locked out and he has to call customer service, and he just beat me at golf last weekend. I'm going to sit there and just try to log into his account repeatedly so he can't get to work because I'm petty and I do stuff like that. But what you can do is you compare a system like that, and this is going into some of the stuff that we didn't talk about. On the server level, you can use technologies like fail to ban, which will actually ban IP addresses and IP address ranges from even being able to talk to the server with your firewall. So you could say after somebody tries to log in 5 times unsuccessfully, put them in a fail to ban jail, and now they can't even talk to the server. And it goes to not just application level security, but infrastructure level security, because now you have multiple applications working together to lock things out. But yes, after somebody has tried to log in a certain number of times, locking them out is useful. If an IP address has tried to authenticate multiple times unsuccessfully, locking them out entirely is fantastic. A lot of the brute force attacks you're going to get are frankly going to be from refrigerators and microwaves that are internet connected and have been hacked and are used as botnets to just try to brute force things. I once worked at a place where our systems guy did not understand that, and when I looked at our access logs and I saw that we were getting between 1,000 and 3,000 failed authentications for our CEO's username a minute that somebody was trying to break in, he said, "Oh, don't worry, I just change his password every day. He never logs in anyway." And that was his way of solving the problem. It was not actually a solution. So trying to detect when someone is breaking into your system, having proper logs in place, responding to those logs, you can automate a lot of that with fail to ban. Some of it is dealing with intrusion protection systems or intrusion detection systems, where you can actually send every request through an intrusion detection system and it will give you a score. How malicious does this request look? Is somebody trying to guess where PHPMyAdmin is on your server, or are they just trying to log in multiple times? And you can leverage all of these different passive technologies to try to protect your application from people explicitly trying to break in. Yeah. Sometimes. With the push notification, there wasn't as much code there because the libraries are a couple thousand lines by themselves. So it's dropping a library and then some glue code to add it into the application. The TOTP stuff, there are libraries out there. I haven't looked recently. When I wrote all of this code, all of the TOTP libraries that I wanted to use were out of date, and we're also taking some liberties with the spec. So the spec is open and meant to be implemented the same way across all devices. Google, Apple, and Microsoft, however, implement things differently. So for example, that 16-character code works on all 3. You can also write codes that will actually be encoded in a certain way that they will work in Google, but not on Apple and not on Microsoft. And some people who only have Google devices or only have Apple devices will only test on a Google device or an Apple device. And when they get a library to work with their device, they will then ship the library and say, hey, it works. The code that I wrote was actually forked from a library that was in existence that worked on Google, newer Apple phones, not older Apple devices, and not Windows devices. So it was just a subset of devices. So I took their library, forked it, and went back to the original spec and filled in the gaps so it would actually work with different systems. So yes, there are libraries out there. I would take a look at the libraries and test on different devices that you need to see if there's one that fits for you, fits for your framework, and also fits for the version of PHP you're using. Some more security-minded individuals will mandate PHP 7.1. Some are already starting to mandate PHP 7.2 just because they want people using the most forward-looking version of PHP. Even though 7.2 won't be out for another 2 weeks, they're still mandating it already. So that's why, even though I wrote this code and I said it should require PHP 7.1, I wrote it that it would work on PHP 5.6. So the fact that it would not work on the PHP 5, that surprised me. But then when we ran those messages, it turned out the PHP documenter, which is a development dependency that came as part of Slim, even though Slim is said to work with PHP 5.5 and above, PHP Documenter has now said it, they require PHP 7 or above. So even though everything else said it'll work on PHP 5.5 and above, this one tiny dependency said it wouldn't. And you might run into something similar with TOTP libraries. Just test it. Just throw it in, make sure it works. You don't have to do a line-by-line comparison. Whenever you're doing anything that's security related, you do want to at least take a look at the underlying code and make sure that it looks okay. Since we're talking about like RNG coin and Bitcoin and whatnot, CoinHive is it's another online website that allows you to mine Monero coin like in your browser. And some people actually took the CoinHive miner and embedded it into a couple of other packages that then got distributed to some very large websites that did not realize that everybody who hit their websites were mining coin for some nefarious hacker who had embedded their application in somebody else's code. So you always want to make sure when you're downloading anything that's security minded that you want to double check and make sure people aren't installing their own backdoors. Like 0.00000 will always work as a TOTP code. Some people will do that for testing, forget about it, ship the code to Stack Overflow, and then somebody else will copy and paste it and actually release it. No nefarious intent, but you might end up accidentally installing a backdoor in your application. That's awesome and so horrible at the same time. Don't store sessions in cookies. Yeah, don't store the contents of sessions in cookies. Yeah. Don't trust your users. Don't ever store any state in the user's browser. So don't use cookies. Some people are using the Jose spec, JavaScript object signing and encryption, which issues something called JSON Web Tokens, which are signed tokens that you can then use for different things. If you ever use OpenID Connect, that's how Google and Twitter and other organizations will authenticate against each other. And people are starting to use that as, here's a way I can have like a securely signed browser-based session replacement, but don't use that. Don't use that. Use PHP sessions. There are ways you can make PHP sessions more secure. You can lock down your data storage. So PHP sessions, for example, are actually stored in the file system in plain text. I actually write a library called SessionZ. You know it's cool because that's a Z, which is an abstract interface for sessions where you can just use regular sessions, and it replaces the session handler to store your sessions in a database or in Memcache in external data storage. And there's also a layer of encryption on top of that. So wherever you store it, it's encrypted at rest. So if somebody even were to breach in and get into that flat file storage or database storage, it's encrypted. As far as configuring session timeline or lifetime, that all depends on your application and your user's use case. Some people will make it like sessions will live for a month because somebody might just want to come back and not have to log in again. That might work for you. That might be a horrible idea. You might only want sessions to live for like 4 hours before it automatically kicks out. It's going to depend on what your application is actually doing. One thing that I've seen a lot of people do is actually set your session cookie to be tied to a browser session as well. So as soon as you close the browser window, the session is gone. Because now your session cookie, which lived in the browser, once you close the browser session, you've lost the cookie. You have to log in again. Now that session might still be valid because it might live longer on the server, but you've now given the user the ability to like go to a public library, log in, and then close the browser and be implicitly logged out. But still, you're going to want to have sane defaults for how long your sessions live to prevent that from being picked up by Firesheep or Wireshark or anything else. So definitely use SSL, TLS. You always want that. You want to be using secure cookies. you want to be using. In this case, I did not use HTTP-only cookies because I was explicitly using the fetch API in JavaScript to send things back and forth to the server. If you do not need that, you can actually tell your server to use HTTP-only cookies, in which case JavaScript cannot access your session cookie. So fetch would not work. It would have to re-authenticate in order to do anything. Once again, depending on your application, the attack surface is very different for everybody. So those are things that you'd have to sit down with the rest of your team and figure out where do we want to compromise security for usability and vice versa. You use the cookie to store the session ID. The session data always stays on the server, but the cookie just stores the session ID. It's like PHP session ID or something like that. But that is if you use secure cookies HTTP only, and you have your server configured to use TLS, so it's HTTPS, and you configure hypertext transport security HSTS. You're doing a bunch of different things that are going to make it so it's very difficult for anybody to bypass that security, because now you're only submitting cookies over SSL, so they're always encrypted. You're only submitting the session ID, but once again, it's over SSL, so it's always encrypted, and you have locked it down so that the browser knows to only ever send that cookie over SSL, to only ever contact that domain over SSL, and to not allow JavaScript to access that cookie. Well, thank you, everybody. You've been great. Hope you enjoy the rest of the conference.